Hello, good evening friends. Study with Apala. Chapter 2nd, The Earth. The concept of half-lives may be explained with the help of a simple geographical representations depicting the decay of 1 g of a radioactive element with half-life t half of 10 years. After 10 years, one half of its quantity of or zero point 0.5 g's would have been decayed to a stable end product. Now the one half of its quantity or zero point 0.5 g's would have been decayed to a stable end product, and so now the remaining 0.5 g's form the starting mass for decays during the next half-life. Only half of this mass, example 0.5 into half is equal to 0.250 grams, would decay. Similarly, at the beginning of the third half-life, 0.250 into 1 half is equal to 0.125 g, so would decay, leaving behind 0.0625 g as the original mass of a decay according to the same patterns, and hence a half-life of 10 years or any value of that matters does not signify that the total mass of any radioactive element will completely decay in twice the period of half-life. In these pictures, half-life explain 0, 0.125, 0.25, 0.325, 0.5, 0.625, 0.275, 0.875, 1.125. This is the graph, and this indicate by mark 0, 10, 20, 30, 40 half-life in a year and grams. Methods. A number of methods based on radioactive decays have been used to determine the absolute age of the earth. Of these methods based on uranium, lead, thorium, lead, rubidium, strontium and potassium argons involves the determinations of exact amount of the parent daughters element of the system. Method based on ratio of different isotopes of lead found in the same samples have also been used to give better result. First, uranium lead methods. Uranium is the heaviest element occurring in nature in two isotopes, uranium 235 and uranium 230, uranium 238 and uranium 235. So both of these isotopes are radioactive that produce stable isotopes of lead 206 and lead 207. So the end product lead of either type of disintegration as radiogenics lead to differentiate it from common non-radioactive pure lead. The decay of uranium isotopes take place according to the following relationship: uranium 238 8 He helium power 1 say plus lead 205, uranium 235 7 helium 4 plus lead 207. So half life is equal to 4.5 4.50 into 10 to the power 9 years. Half life is equal to 0.71 into 10 to the power 9 years. Thorium also disintegrates into another lead isotopes Pb 208 according to the following relationship. Thorium Th 232 is 6 heliums 4 plus lead 208. Half-life is equal to 1.39 into 10 to the power 10 years. In rocks is the determinations using uranium. The product procedure involves spectrometers analysis of the specimen to determine the exact amount of uranium isotopes and lead isotopes age of the specimens is then calculated by the relationship. Lead 206 is equal to uranium 238 E lambda 8T minus 1. This is formula. Whereas Pb lead and uranium specify the amount of isotopes. Lambda 8 is a constant depending upon characteristics of uranium 238 and T is the is in year. Uranium lead isotopes analyzed from different part have given the maximum age of the samples samples as 3.6 into 10 to the 9 years. This simply means that the Earth cannot be younger than 3.6 billion years. The minerals pitch blends is the source for such isotopes. Rubidium strontium method. Rubidium 87 undergoes radioactive transformation to strontium 87 by emitting uh, beta rays with a very large half-life, T half of 4.7 into 10 to the power 10 years. This provides a very reliable methods in determining size of some easily available soldest rock. The source minerals are different varieties of mica such as lepidolites and muscovites. Method consists of determining the total rubidium and strontium content of the sample by latest isotopes dilution techniques. The age formulas for rubidium strontium is as follows: T is equal to 7.2 into 10 to the power 4 in strontium 87, rubidium 87 plus 1 in bracket, where T is of the specimens in million years. Strontium and rubidium indicates number of radiogenic atoms of the respective element. This method has yielded is of 2700 million years for the specimens studied. Lead lead method. So this is known that different isotopes of radiogenic lead may be produced in the same samples by decay of different isotopes of uranium. So easy to 235 lead 207 and uranium 238 to lead 206. The ratio of radioactive lead isotopes lead 207 by lead 206 formed during the decay of uranium in itself offers an easy method for finding out the age of the sample. It is easy because the job involves to measures only the ratio of lead isotopes. Age of the sample is determined using the relationship lead 206 upon lead 207. So uranium 238 upon 235. E lambda 8T minus 1, E lambda 8T minus 1. This is formula where T is the age of a specimen. Metric lead methods, it is considered as the most reliable methods for determining the age of the earth. It is based on the isolation of lead from iron and stone meteorites. Their isotopic compositions are determined and compared. The age of the earth calculated from these ratios is around 4.6 into 10 to the power 9 cs. This is based on the assumptions that the meteorites are also planet like small bodies that have been formed in the solar system at the same time as our earth. Conclusion: radiometric age determinations gives a broader limits about the age of the earth. The age determinations on the granites of Greenland and from so many other continents is around 3.8 billion years. Hence the earth cannot be younger to those rock formed on it. This is the lower limit. Is determinations on numerous samples of meteorites that are almost conclusively believed to have formed at the same time from the same type of source material as the earth provides data indicating upper limits around 4.5 billion years. Moons is believed to be as much a part of solar system as the earth. Radiometric datings of lunar rocks samples have also indicated age of 4.61 billion years. Hence, as a matter of safe estimate, we may make an inference of age of the earth at 4.6 billion years. Thank you. Like, support and subscribe this channel. Thank you.